So what we're going to do is we're going to put everything we've now seen with calculus, all the different tools, into one menu, if you like, and a way to approach to draw not just a rough sketch, but a really good sketch. So things to look out for. Now, way back earlier in the year, we talked about pointed discontinuity, things like that. So we still need to be aware of that. You know, the bottom of the fraction can't equal zero. I'm going to have a vertical asymptote, those sorts of things. And as I was just saying, so yes, that might create not only vertical asymptotes. We've got a curve like y equals x plus 1 dot x. We know we've got an oblique asymptote at y equals x. So those ideas are still important. But now we can add to it our calculus ideas. So on the curve, we know stationary points are going to occur when the first derivative equals 0. So that's the first thing we're looking for. Where's it going to turn? Those sorts of ideas. Once we've got them, we can classify them. If it's concave down, we know we've got a maximum turning point. If it's concave up, we know we've got a minimum turning point. Now, reality of the situation, if we're talking about a smooth, continuous curve, there has to be an inflection point between a maximum and minimum, because it's got to change concavity somewhere. The reality is I probably aren't going to bother finding points of inflection unless they specifically ask me to. So for the sake of the example that we do later on, I'll find it. But remember, that's where the second derivative equals 0, because there's a change in concavity, but that's a possible inflection point. To confirm it, depending on how difficult it is to differentiate, we can use the third derivative not equaling to 0, or for either finding the nature of stationary points or inflection points, if it's easier, just draw a table of values and sub some points in to see what's happening around it. And that's what we'll do if it's a bit difficult to differentiate. Now, if we're still not sure after that information, we can use the derivative to see when the curve's going up, increasing, or going down, decreasing. So we'll have a look at the sign, basically. Is it positive? Is it negative, the derivative? And if we're still unsure, we can have a look at the concavity. When's the second derivative greater than 0? When is it less than 0? Okay. So those last four, I guess, are really if we're just not sure what's happening. So let's put one together. It is just a cubic, a nice polynomial. So I sort of know what I'm expecting here. Remember, all cubics will have only one inflection point. Well, let's find the tools that we're going to use. There's my first derivative. There's my second derivative. There's my third derivative. First of all, locate stationary points. So first derivative must equal 0, and I get two possibilities, x equals 1, x equals 3. Now we go and classify them. And x equals 1, I get a negative. So therefore, concave down, maximum turning point. And x equals 3, we get positive 6, minimum turning point. That's usually enough to draw the curve, as I say. But for the sake of the example, let's go find our possible points of inflection. And that's going to happen when the second derivative equals 0. So my possible one is x equals 2. Now I'll classify this. Well, when x equals 2, the third derivative was 6. In fact, it's 6 everywhere. That does not equal 0. So yes, there's a change in concavity. Yes, it is a point of inflection. I probably should have added in there is a change in concavity there. That should be enough. So let's plot the points in. We had 1 minus 1. And down there, 3 minus 5. This can also confirm as well, by the way. If I'd found 3 minus 5 was a maximum turning point, then I've done something wrong. Because there's no way that could be a maximum, the other one be a minimum. And there's my point of inflection. Y-intercept, that's pretty easy to find, so negative 5. X-intercept, solve a cubic, bit hard, not going to worry. Because look what I do. Oh, I cheated. It keeps going. It will cut there somewhere. I just don't know where. And I'm not going to worry about finding it. So that's a pretty accurate sketch, other than the x-intercept, I guess. Okay, so 10F, 10G is basically putting it all together. Let's draw some interesting sketches. Some of those will probably have asymptotes and things like that.